All right, so let's begin. Yeah, so last time we did historical we encoded previous we basically took game state in the game state when we're discretizing game states, right? We what do we do? We added a field to the game state called the prev game state, right? Like a back pointer to make it like a linked list to like point to its previous game state, and then like that points to its own previous game state all the way to the beginning, where I guess it's either undefined or points to itself. Unclear about that, but currently it's undefined. So then basically if for the very start state, right? So when we're encoding the basically the whole idea I talked about last time was to encode velocity by passing in like some k previous frames, k previous game state coins. So like the neural net can like see the positions of like not just the coin at like the current time, but also like a previous time, and from that like deduce, get some sense, some notion of the discretized velocity. So because again, we can't really like directly encode the velocity into our neural network input. So this is all like this discretization of game state is about like how we represent it for the neural net's input, right? So anyways, yeah, so I said that like because of this we have to change apply move to at the end of the stream I was talking about apply move considerations, because like when we apply the move, right? Like if we have game state like ABC, like we're currently at C, and then we hit game state D, then like the new game state like C becomes D, but that's a destructive operation, right? So like we need to kind of like do some cloning, some copying to make everything work. Now don't worry, I'm gonna draw this, but I wrote some notes. I'm just gonna pull that up. I'm just gonna wiggle this a bit to make sure that OBS is capturing my scene and not just my webcam. So it is. So anyway, so here's what I just wrote. I literally just wrote this like 3 minutes ago. So last time I thought about a process that involves lots of excessive cloning, I think 2 times. Start off by drawing whiteboard and then skip this and then uh, draw my improved idea again. Okay, so let's just start, right? So first of all, let's just delete that and like create a new whiteboard. Okay, let's just create a new one. I think that one was dirty with a bunch of LeetCode nonsense. Accept all cookies, whatever. Okay, so like basically like I was thinking of like kind of like how to talk like let's say we have a linked list, right? Now again, like linked lists typically go left to right, at least, but this is kind of a reverse linked list, like with back pointers. Instead of next, you have prev, right? So let's say right now, basically I'm maintaining right now. Wait, also in my terminal, I mean, since last stream I created I pushed the changes. That's why like the git status shows clear, but nothing, I didn't do anything else off stream except like save it, and like I also deleted some comments, I think. Like when I was console.logging the image stacks. Yeah, so it's git status basically shows clean. Let me just do a git log. Yeah, add historic coins to game state representation. So that's what we did last time. Like, right? So basically, like all that was done like last time was like this key, like line number 6, right? Like this, like this line that I'm highlighting, num game state set to 2, and then like basically it's usage too, right? And then it's used right here in K, and the index variable, the variable of indexing K, where we have this very elegant like generalized like this very nice like notion of like features. Like K is like the feature for the which game state we're on, like historical index, where 0 means current and 1 means one past, one prev, and so forth. It nicely generalizes. So basically, like this is basically like the idea that we did last time. We introduced that, and then this. Oh, I didn't comment. Let me still delete that. Let me delete this log statement 36 GG. Let me just delete that because like I already like kind of did a whole bunch of print statements in the console and like kind of looked at everything, like stepped and like looked at thousands of zeros and ones. So like, yeah, status get diff. So anyway, so the point is that like we kind of be like sorry, not just this, like this was like the main thing, like this was the bulk of the stream, like introducing this, but also to the mechanism behind actually implementing these previous historical game states is this, which I'm highlighting here, car game state.prev game state. Like these two lines, when we advance it to the previous. Now actually, advance seems a bit like the wrong word. I guess advance and prior is a bit kind of, what do you call that, oxymoron? A miss like a bad, like it just doesn't fit, misfit, or like a, yeah, these words don't fit together very well. It should be more like rewind or something maybe. But anyways, I'll leave it as is. Because I like thinking about terms of advancing and like plus pluses, like we're advancing but in the previous direction, right? Okay, yeah, that's a good reconciliation. So then, like, the whole point is the mechanism behind advancing is this notion of a reverse linked list. So we introduced this field prev game state onto game state, right? Okay, my notes need to come back up. Yeah, so I'm gonna do some whiteboard drawing, but yeah. So the point is that, like, let me open up the other file too. Let me open up gamestate.cs. The point is that now our like we introduced this new field, which I'm highlighting in line 12, prev game state, right? I have to sneeze. It's gonna come out soon. But like the problem with this, you see this apply move function right here, like which I highlighted. So apply move, right? Like currently what this does is, like, because we introduced this prev game state, now apply move actually is incorrect. Like now apply move is actually wrong, because like what apply move does, right, is it takes in the move, it finds the coin, matches, like the move has the coin ID on it, like there. It searches all the game states coins, it finds it, it does some error handling, but like the happy path is it finds the coin, and then what it does is it like actually like kind of it applies the velocity contribution that the move tells it to its coin's velocity, and then it basically advances the state, right? It just advances the state, like lets it play out. Like in connect for analogous is like dropping the coin, computing the position the coin will land, like the first unoccupied tile from the bottom up, and then it just adds it, right? It basically like takes the move and applies the move. That's why it's called apply move. So here's where like we're actually applying the move. Like once we found the coin, we apply the move to it, right? And we just like let the physics engine like step through to like move the coin and like handle the collisions and do all the physics stuff. Just let the game kind of unfold a bit, right? Because like real-time games, everything just happens all at once, right? Like that's what time is. Like I heard that quote somewhere, right? Like time stops everything from happening all at once, right? So we're kind of like discretizing time too, like the energy system. I talked a lot about that at length, so I'm not going to repeat that. Will I? Maybe, who knows? I tend to repeat stuff a lot. But anyways, the point is that like right now, like this is kind of I must say, a destructive operation, right? Like we're taking the game state and we're mutating the coin's positions, like because like these lines right here, these four, like three lines, well, four lines basically, like these four lines of interest basically are kind of mutating the game state. And then like in now, like we're kind of doing a skip, like our pointer to previous game state is now like it's being messed up. Like okay, let me actually like do this in the whiteboard, right, to show. Like that's what I was thinking. Like you have like 1, 2, 3, right? Let's say that this is your current like game state. Like game state simply points to like, it's like kind of like a reference. Like you have like in Git you have like the label head, which points to like the head, right? So this is your game state, which is 3, right? So every time, like let's just say that like instead of like the positions of coins, we just like have a linked list of the val, like a LeetCode thing, where like instead of next it's prev. So like we have game state, which has like the number 3 in it. Its past game state was 2, and then that past game state was 1. So like this is like GS, prev P for prev, and then GS PP for like prev obviously. So like but the point is like that's the whole idea. So we have current game state, right? Now currently what apply move does is it takes 3, which is like the analogous, 3 is like analogous to the coin's velocity, and then advances it, right? It advances it by 30 ticks, update, advance, whatever. it does some plus plusing, right? So from 3 plus plus, like 3 equals, like we kind of advance that. So then what happens after update, like after, like basically after we do apply move, right? This 3 becomes a 4, but the prev pointers don't change, right? So now here's what it looks like after our current apply move. So there's a bug, right? We skipped over, like we did a destructive operation, and we've now ruined, like here's what we look at now, like our GS now after doing apply move. This is before and that's after, like that's after, right? So after doing apply move, we now have 4-2-1, but this is incorrect. Like this is wrong, right? What we actually want, which is right, it's like that meme, is like what we want to see is we want to see 1, 2, 3, because we did a destructive operation on 3 to get 4. We want to see 3, and then we want to see 4, right? So this is kind of like the desired outcome, but we currently have this. Like we're here, but we want to be here, right? So what I was thinking of doing in the apply move itself, which I realized recently that that's probably not the elegant way of doing it, it's a bit wasteful, is what I was thinking of doing, right? Is taking this 3, and I was thinking of cloning it. Like, in fact, let me just kind of like, well, I can use ABC, right? Instead of 1, 2, 3. Because now we're kind of being, like, when we use like variables, we feel smarter because it's more abstract, algebraic, symbolic, whatever. So if you have like C, B, and A, or let's just say CB, right? We have CB. Okay, we have BA, whatever. So we have like, and this is our current, this is our like kind of our GS, right? Then what I'm saying is like we can kind of like create like a new copy of B, right? Like B2, we can kind of clone it to B2. It has the same coins, like a deep clone. A deep clone just means like recursively clone everything. So like they're completely separate. All the constituent members of B2 are different, are like deep copies of B1. So like changing one thing, like taking B2's coins and changing it won't like mess up B1's coins. It's like immutability, right? But anyways, the point is that like we'd kind of like take a copy of like, remember how like 3 got destroyed? Like we want to kind of preserve it. So like we'll take B1, and like when we're doing it, like we're calling apply move to the game state, which is B1 backpoint C, right? Well, B. The 1 is just to like kind of differentiate the copies, right? So we basically clone the current head, the current game state, and then what we do is we or like basically like we clone it, and then we apply the plus plus, right? We apply the plus. Oh wait, this, why is this C? This should be A, right? Let me delete that. Okay, good, right? So this is A, right? So then now what we do is like we don't want to mutate B, like, because like if you go back to this case where we had 3, we destroyed it, like we updated it to 4 by doing apply move, but that was a destructive operation. We lost the 3, right? So that's what I'm saying. Like rather than like mutate stomp over B1, we'll make a clone B2, then stomp over that. So this one basically will become C after we do apply move. So now we have C, right? So now we have C, and we got C by cloning that. Let's have this as a clone operation. So like we kind of have like a clone of like B1, we clone to B2, then we have C, right? And then what we do is we take C, and then we kind of wait, no, this is wrong. Sorry. This is not it. This is not it. This is not it. We so what I was thinking, right? What I was thinking of doing was cloning this, and then taking this B1 here, which we're applying move to, and then I was thinking of making this one C, I was thinking of making B1C. So like B1, I shouldn't make this arrow sign. Seems a bit, it's like this B1, we apply the move, like basically like see, we have this 3 here, right? We have 3 here. What I'm saying is like we kind of store 3, like, because like right here what we're doing is we're destroying 3. So I'm saying is like we should kind of like create a 3, like we should kind of like keep a stash of it, make this 4, and then like adjust the links properly to do that. And I think I did this in the end of last stream, right? Maybe symbolic was bad and I should have kept it with numbers. But anyways, basically like we have A and we have B, right? Which are the game state. Then we kind of we keep a copy of the B so that we don't stomp over it. And then we take this one and then we advance it. So B basically becomes C. And then like this clone, like when we clone B, we also clone its previous pointer. So now that we have like C, we now replace its prev pointer to not point to the old prev, which is now prev, but instead point to that which we cloned. So now we are done. Now we have CBA. So the final outcome is what we want, CBA. It's not CA, right? Like it's not CA, it's CBA. But the problem with this, now what I'm maintaining is that like apply move should not do the clone, because like in the actual, like if you look at the actual if you less the MCTS, right? Oh, that's not there. If you less connect for MCTS.ts, right? If you look at where apply moves actually used, right? Because ultimately like this whole thing is MCTS search, right? It's used in the search, right? In the case where we hit a leaf node, like we want to take the UCB, the best action that has never been taken yet. Because if it's been taken yet, it points to an existing MC Monte Carlo tree node, right? MC node. But here we've reached a leaf. Like, I mean, we have to create a leaf. Sorry, we have not reached. We have to create a leaf node, right? Like we have never taken this action yet. Like it doesn't have the node. We're in the else case, right? Then what we do is we like basically like next game state. What it's doing here is it's cloning the game state, right? It's cloning it. The game state is being cloned, right? So I'm saying that like we're already doing a clone. So apply move doing a clone would be super redundant, right? So what I want to do is I want to pass in what we have cloned, so that like we can kind of like put it in there and like kind of set that as a back pointer to what we've passed in. Now, what I just said might be a bit hard to digest, and it is for me too. So I'm just gonna draw like right now. Here's like the proposed mechanism where like apply move does clone, right? I'm going to first show this example, and I'm going to show that it's bad. And rather we can pass in the game state itself. So like here's kind of the idea. Like the next game state, like here, like let's take a step back. Look, connect 4 does it, right? So we have some game state, right? And now if we were to apply the move, like that, like let's say that let's say that we have some game state A, right? And then we apply move on it. And then this basically is a destructive operation, right? Like it takes in the game state and it adds the move, it drops the coin in the column, and now the game state has been altered, right? But the problem with that is it's destructive, right? So like this new leaf MC node would have the correct game state, but its parent's game state now becomes the same one, right? Ultimately like you need to clone it, because like each MC node has its game state is different, right? Like you can't, like it's immutable. Like you cannot do destructive operations to it. Like you can't apply the move because that would like change it. That therefore like this is the logic behind having this clone, right? So like the idea is that we kind of get a clone, a fresh state to work with, so that we can do whatever we want. We can apply move, we can do wacky things with it. And then because it's a deep copy, it's not going to mess up the existing MC node's game state, right? Like when we're doing search in MC node, we don't want to actually like mess up the game state, right? We don't want to apply the move to it. We want to apply the move, like the child should have the move reflected, right? The point is we don't want to do destructive operations. That's why there's a clone. right here, right? That's the whole like kind of idea behind it, right? So now let me show like why if we do like a clone and apply move, like there'll be an extra like a 2 times I think factor, or like there'll be a bit of redundancy. So let me kind of show an example, right? Let me just actually like kind of show what I mean by like this clone being redundant. I'm saying that rather than cloning it inside the apply move, I'm saying that we already did a clone. We can just pass it in to apply move. So like apply move would become apply move edge to take comma move, comma, like we'd add a new parameter. It won't just be like apply move takes in just one parameter, the game state. I'm saying it should take in 2 parameters. The game state we're going to destructively apply the move to, and a clone of it, and a clone. Or wait, no. The point is that we're going to pass in the node.gameState and the next game state. The point is we're gonna like pass in the clone, so we don't have to do the cloning. Okay, let me just, that was a lot of words. And again, don't worry, I'm gonna draw it all out. Partially for myself. So like let's just say that like this is a C, right? This is our game state C, and this outer wrapper is our node. So like the bigger circle means the MC node, right? Like this tiny wrapper is the game state. Wait, why is my GMS look the same? This is my game state, and like this whole thing is the MC node, Monte Carlo tree node, tree search node. I think I'm gonna write notes, right? That's kind of like the interpretation of this, right? So we have C, right? And then what we're doing here is we're kind of cloning the game state, right? So again, cloning, I've decided by convention is to do it based on the based on like this kind of this line here. So the point is that like we take this C, which we have, which let's call that C1, and then what we're doing is we're cloning C1 to C2. So these are both 2 different objects that have different coins that just happen to have the same locations and different fixed point numbers too. Like everything is different, right? So it's a deep copy of C1. So like we have C2, right? So like right now we take the next game state, which is a deep clone, and then we do the apply move. So what apply move does with this cloning proposal, if we do the clone, is we take apply move, right? And then what we're going to do is we're going to create C3, right? We're going to create C3, store that, then take C2, and then kind of advance it to like D1, and then make like, okay, and then let's say that C1 points to like you have a previous node, and it points to like, let's just pretend that instead of C, we're working with A. Or actually, no, C, whatever. Or actually, yeah, let's make it A, right? Actually, no, let's just say that it points to some prev, some prev. It points to the games, like game states. Prev is a game state, not an MC node. A node is just a wrapper class. That's it. MC node is just a wrapper on the game state for the intents and purposes of now. We don't care about the statistics, like the whatever Q scores or whatever, like the edges and like the num visits, all that we don't care about. We're just in the context of pointers, right? So basically, like so to recap, we took our node, which is this node right here, and then we took its game state and we cloned it. So then from C1, we made a copy of C2, right? And then we're calling apply move on this game state, right? We're calling apply move on the C2. So what we do in the proposal where we do the clone is we clone it again to get C3 as kind of a what do you call that? Yeah, just a copy, and then we kind of like in that clone again, like its prev pointer is the same pointer, like it's the same remote, the same reference. So its prev still points, like its back pointer still points to the same whatever that one pointed to, right? So now, and then this D, like we apply the moves, like we took C2, and we don't want to apply the move directly because that destroys some information, right? We want to like save a clone of it, and then like D1 would back point to our copy, And then the copy also back points to like whatever it should point to, because cloning copies the reference, right? That's straightforward. So now we take this D1, right, which we have, and then we kind of wrap that in a new node. So this node now points to that, right? This looks pretty messy. I know. But then so now we have D. So this C2 becomes D1, right? And now let's just do this again. Let's do this let's just kind of let's just rewrite this whole mess, right? We have C1, which is like, and then we have like the node, and then the child node now has a game state D1, right? C1's prev is whatever, like some prev game state. Let's call that B, whatever, and like dot dot dot, so forth, keeps going up the chain. Now D1, right? So D1's prev is not this C1. Like D1's prev is actually C2. A copy. Like these are like kind of like siblings, like which are the exact same, like a waste of space, right? And that one's prev is that. So then when we do this again, right? Like once we do this whole process again, like repetitively, we'd get like E1, like that. And it doesn't point, its prev is not D1. Its prev is instead a clone of D1, because it's the clone that like, it's like when we did apply move, like we did a clone, right? So like that's what happens. We're kind of like it's the clone that we did of D1. Why does it look like P? Or sorry, D2, a clone of D1, right? And then D2's prev is whatever this one's prev is, right? So ultimately, if you look at the game states, they're all pointing to like look at the number of game states. Like if you have like, let's just kind of like zoom out. Like it'll look like this, and like what we expect. Like, and like each of these have their own circle, and like the expected outcome, which we'd like to see, is like what we expect is this, where everything kind of like each circle, like it's like we expect like an arrow from there, an arrow from there to there, an arrow from there to there. Yes, the arrow only has one head for my convenience, from there to there, and so forth. This is what we want. But if we kind of implement the mechanism of cloning in apply move, then we're going to get extra redundant clones because of the clone in there and the clone in here. So what like we're going to have, which is the wrong thing, right, is like what we're going to have is a bunch of extra clones. Where like this one's prev points to this one. Wait, what's the topology? This one's prev and this one's prev. No, sorry. Okay, so this one, so this one's like kind of like E. So its prev is kind of like that. And then so this one's prev is that. And then that. Or the outer circles are just the node wrapper. So basically, like rather than being direct, we're gonna have like each dot has like a twin. Like there'll be like 2 times the number of game states, approximately. except for starting node maybe and ending, or some off by 1, off by 2 or something. But that's kind of like the whole like the problem with this. So then what I'm thinking instead is like, rather than like doing the clone like inside apply move, what I think is like we just take in the game state, right? The game state which we're not going to mutate, and then we're going to treat that as the cloned one. So apply move will now take in a new parameter. Now this actually breaks the API. Like this breaks this is MCTS. Apply move when invoked in MCTS only passes in like just it applies move to just the it applies move on like the copied game state, right? And it takes in the move. But not only should it take in the move, it should also take in like a new game state to point to. That will now be our ancestor. Because when we're applying the move, we're stomping over this game state. We're doing a destructive operation on it. We're changing the velocity of the coin. Like we're doing some destructive operation on it. So we need to like kind of stash it. And guess what? We already have a copy. The very game state, the original game state that we copied is also a copy, right? So we can just pass that in. So that's all I'm saying. Yeah. If you look at like, so again, like back to that file, like this expects like we need a clone on the game state, right? So we definitely need to know the clone like game state dot clone is there for connect 4, right? Like if you like kind of look at like less game state cf, right? .ts, then like we've been like kind of implementing all the methods, but we actually did not do clone yet. Like we have apply move, get legal moves. I already mentioned I might fold that into net.ts. It's only used there. I did a grep on that in a prior stream, and we have clone. Let's pretend that let's just kind of like stub everything, right? Just kind of add a stub to that. cf.ts, and we're just gonna like copy the method signature that's already there. It's like there's nothing wrong with that. Just to get the just to stop any errors from happening. Compile time errors. That's line 149. Just copy that. Again, it'll be an empty function. It does nothing. It's just a dummy, just to like stop the compiler from complaining. We're treating it as a black box. Let's pretend that it does a clone. It's not been implemented yet, but just pretend that it does. So now we're gonna have to like kind of. So this is just to like we need this function on any state, because the Monte Carlo search it expects states to have a clone feature, right? When it's actually like hitting a leaf node and it's going to apply move on it for the first time. So now when we apply the move, we're also going to take it. I was thinking of making this an optional parameter just to preserve it, but I do want it to like force an error, so that I'll have to edit MCTS search function to pass in the new thing too. So we're also going to take in like a copy of game state, or actually let's call it like new prev game state, right? Because once we got like from C to D, then this D has to point to, rather than like this C3 here, it should point to like we want it, like you see how like all these arrows, like there are like a bunch of like kind of like arrows going this way, like here, and there'll be arrows going that way in diagonals. Like we have like these three like directions, like three different like two main lanes, like that way. Like we have kind of like we have like everything is like these are the node arrows. Like yeah, the nodes have arrows to each other too. The left arrows are like the node to node, and the right arrows are linked to game states. So I'm saying rather than have a bunch of extra like excessive clone copies, just simply pass in the previous game state, right? So like we just kind of pass it. Let me just actually show this in action, right? Let's just show it in action. So then like we just take the new prev game state, and then once we do the update, then we will take this dot, what's it called? Prev game state. And set that to new prev game state. Now I was thinking of making an optional parameter where if it's not defined, we can just clone this, but that's just weird. I should put a comment there then. So now if I just kind of like go back to this MCTS, right? Huh? It's like, let me just make this an editor. So now apply move, right? Should also take in node.gamestate. That's what I'm saying. Like this whole point. Now, yes, I did mess up the connect fours directory because this is actually like a different, like if you look at the highlighted line at the bottom, this is like the sibling directory connect fours MCTS. But I did make a mutation. But the thing is, that's already saved in the public GitHub in BumperCoins. Like anyone can look at that. It's already saved. So I don't mind destroying because I'm basically done with the project. I mean, there are like a few more tweaks, maybe some more polish to add, but that's more of like kind of self-congratulation. That's like the stuff is already done. Like connect four, we'll move past it. I've already added those finishing touches. So anyways, so now let's take a step back. So like now what we do is like we take our game state, we clone it, and the reason we clone it is because this new next game state, we can do apply move, which is destructive. Like it changes the coin's positions, right? So like we don't want the changes to be reflected in the current, like this game state. Like the node.game state should be immutable, right? Its coin locations, whatever game state, whatever members it has, they should not be mutated. We don't want to like dirty it, stomp over it. We want to preserve that because each MC node has a snapshot. Yeah, I think the word snapshot is a good word. It contains a snapshot of the state of the game state. Just it's a lot. It kind of reminds you of Git too, right? Like you have like different hashes, like different commits, like different nodes, like different snapshots at different times, right? Just like how like the MC node is a snapshot of a certain game state, and then the tree search basically lets us kind of like look at future snapshots while not messing up prior. Like that's the whole idea is immutability. So we have a node.game state which should not be mutated. That's like a rule. Then we copy it to get a clone of it. And then this clone we're doing the apply move on. So that's a destructive operation that advances it, and then it sets the back pointer to what? Not a new clone. It just sets it to the immutable game state, right? Like this current node's game state, right? That will be untouched. It'll be pure, right? And then whatever new game state we take, we want its back pointer to point to the current game state. So this is the current game state, and this will be the next game state, right? Technically, in its next game state, we cloned it, and then we apply the move, and applying the move destructively changes the next game state to be the next game state, right? So like this name right here after this line, I could have called it game state clone because we just took the game state and we cloned it, but I called it next game state because like the next is kind of aspirational. Like this aspires to become and will become in the future in the next line after the function ends, returns. hopefully, if it returns successfully without throwing an error, this next game state is now actually it's no longer a clone, but it's actually the next game state. Like C became D, 3 became 4. Like it was a destructive operation. So we have now advanced everything, advanced the positions, handled all the physics changes, and it's now the next one. And what does it point to? It points to the current game state, which we have just cloned. So that's kind of like, that's my proposal. So git diff, if you look at like our actual changes, I think I'm gonna end the stream here actually. Like to do, yeah, I'll add a to do there. So next stream we'll work on a clone. But basically like this change right here, adding this new parameter, argument. What's the difference between argument and parameter? Never mind. But we just added this new argument, new prev games. We added a new parameter and we basically set the link. And that's it. Like however long the stream was, like all that was done is just create this pointer, which is pretty crucial, right? Because like when we're actually like, if you look at like less net.ts, right? Like we're kind of like advancing or reversing, rewinding the game state, right? To like kind of set the game state to itself.prev, and like doing this line a whole bunch of times, particularly that many number of times, twice, lets us kind of like look at the back pointers and see the historical game states. So it's crucial that we populate this, and in our changes we just did right there, right? So that's all. Just, and of course MCTS also has been changed to now mandate 2 arguments and not just the move itself, but also like a clone or the original one. The cloned one is what we are invoking apply move on. It's the self or the this, whatever. So yeah, let's just save that. Status, get add all, git commit. Populate game state dot or populate prev game state in game state dot apply move mcts dot search needs to pass in the node dot game state. Status, and I'll push the rest off stream. So yeah, basically a lot of it was just looking at the whiteboard. Like today we just kind of like looked at the linked lists, looked at this notion of destruction and the necessity of cloning, and then like kind of just give a very simple solution, just pass it in for MCTS. Now the one kind of upsetting thing is we will have to change MCTS.ts, but I mean that's kind of like, that's just how it works, because like Connect 4 does not need, like the game state representation is just the configuration of the chips, like the coins, whatever, like the cells. It's either empty, has a red coin or a blue coin, right? Like that's all it cares about. But now to encode velocity, we need to kind of encode previous states as well. So we need like a linked list or like a sliding window or like some collection of multiple states, right? The historical states. And because of that, it's kind of fair, it's a fair play that we need to propagate those changes to MCTS2. So it's not that general yet. I mean, but the thing is, like, it's only a 1-line change, right? Like, if you look back to here, the proposed change is just, like, this is the only change that I did. I added 1 comma, 1 space, and then node.gamestate, like, that very few characters, right? Like, not that much. Just a very tiny, like, we're not, like, doing a dramatic change on this mcts.ts file, right? We're only just passing in something that we've already cloned. And like, we've already cloned it because like this notion of like non-destructive operations, immutability, like we've already done that consideration. So it's just, now that we have a clone, why not just like kind of copy it, right? Paste it in there. Like we have 2 of the same thing, the original game state and a clone. So like just pass the other one in so that we can point to it. So it's not like Because like we know that mcts.ts is a good file. Like it successfully worked for C4, and like we're kind of just making it work for BC BumperCoin as well. So it's like it's already has a proven track record, so we don't want to like change too much of it. But I think this is a very minimally invasive thing. We're just kind of passing another parameter, so I'm comfortable doing that. I don't want to like change too much of it, but like because this game state representation for BumperCoins BC requires historical things, I think that that's like it's okay. I guess we can make a change. It's like not a huge capitulation. So yeah, like with all that said, like lots of talking, but the only difference now is we're gonna add like this thing which I just highlighted, pass in this extra argument and use it by linking it as the pre game state. The next game state's uh, apply move. Like here, it'll just like take in this next game state, do the stuff that it already does. We apply the move to it. We advance the physics engine by 30 ticks, and then we'll now create the back pointer to point to this immutable, like this clean, fixed, pristine copy. And that's all. So yeah, very little change, but still I think pretty significant. So now the bulk of the work to do is in this clone. And then I think we're more or less done with the historical stuff, the historical considerations. And then after doing clone, being done with the historical considerations, that means we've basically done a discretization on the velocity, because these historical stuff encode velocity. Not only that, like we've not like hard coded 2 anywhere. It's, I mean, we have as a constant, but like we could make it 3, 4, 5, whatever. But I think 2 is sufficient, just so that like, I already talked about this, but I'll leave it at 2 for now. But all we have left is clone. I think we're almost done with the historical aspect of encoding the velocity. So yeah, I think that's all for now. But yeah, I hope that everyone, including me, is on the same page with myself in the past, and that I'll continue being on the same page. So yeah, that's all, I guess.